Imagine a car so ill-suited for American roads that it vibrated violently at highway speeds, rendering the rearview mirror completely useless. A vehicle so underpowered that merging onto a freeway wasn't just difficult, it was dangerous. A sedan that cost more than a Volkswagen Beetle, yet broke down so often that the company lost over $1 million trying to sell it. This was the Toyota Crown of 1958. It sold exactly 287 units in its first year on American soil. It was a catastrophic failure that should have ended Toyota's American dreams forever. But instead of retreating, Japan did something unexpected. They analyzed every failure, listened to every complaint, and spent the next 7 decades engineering the most successful automotive invasion in history. This is the story of the quiet conquest. So sit back, relax, and let's drive into the past. There is something quietly remarkable about the way an entire industry can transform. Not through violence or sudden revolution, but through patience, precision, and an almost meditative commitment to excellence. The story of how Japanese automobiles came to dominate American roads is one of the great business transformations of the 20th century. A tale that begins with that humiliating failure and ends with vehicles so ubiquitous that they fade into the background of daily life like streetlights or stop signs. In 1957, when the first Toyota Crown sedan arrived in California, shuddering so violently at highway speeds that drivers could barely see through the rearview mirror, the idea that Japanese cars would one day outsell American vehicles seemed absurd. By 2024, the Toyota RAV4 had become one of America's best-selling vehicles, surpassing individual models like the Ford F-150 in annual sales. This transformation took 7 decades, countless engineering hours, and a fundamentally different philosophy about what an automobile should be. This is not a story told in dramatic crescendos or sudden revelations. It unfolds slowly like a long drive down an empty highway at dusk, where each mile marker represents another small victory, another incremental improvement, another American consumer who chose reliability over tradition. The narrative moves at the pace of Kaizen itself. That Japanese concept of continuous improvement where progress accumulates through 10,000 tiny adjustments rather than one grand gesture. As you settle into this journey, let the details wash over you like the hum of a well-tuned engine, the soft glow of dashboard lights in the evening, the particular satisfaction of a car door closing with precision-engineered solidity. This is a story about machines, yes, but more fundamentally about philosophy, culture, and the quiet power of doing things right. The Arrival, 1957, and the Crown that couldn't. The modern history of Japanese automobiles in America begins on a warm August day in 1957, when 2 Toyota Crown sedans were unloaded at a California dock. The cars gleamed in the sunlight, their chrome bumpers reflecting the optimism of Toyota's executives who had envisioned conquering the American market. Within months, Toyota had established its first American dealership in a former Rambler location at 6000 Hollywood Boulevard in Los Angeles, a prestigious address that suggested ambitious intentions. The reality proved far less glamorous than the address. The Crown had been designed for Japanese roads, which in the 1950s were poor quality surfaces where high-speed driving was impossible. The car's 1.5-liter engine produced just 60 horsepower and needed a painful 26 seconds to accelerate from 0 to 60 miles per hour. On Japan's rough roads, this was adequate. On America's smooth highways, the Crown revealed catastrophic shortcomings. The engine overheated constantly. The suspension, engineered for bumpy Japanese streets, made the vehicle dangerously unstable at highway speeds. The entire car was too heavy, too loud, and far too slow for American driving conditions. In one memorable incident that captured the Crown's fundamental unsuitability, Paul Ozawa, Toyota's first American sales associate, discovered the car couldn't be taken to drive-in restaurants. When serving staff hung the food tray on the steering wheel, it pushed the bezel and activated the horn, creating an embarrassing scene. The sales numbers told a brutal story. In 1958, Toyota sold exactly 287 Crown sedans and one Land Cruiser in the entire United States. The total of 288 vehicles represented a spectacular failure. The Crown's price of $1,999 was about $500 more than a Volkswagen Beetle, yet the German car offered proven reliability that the Crown decidedly lacked. Toyota lost approximately $1.4 million during these early American ventures. By 1960, the company had ceased exporting the Crown entirely. James McGraw, Toyota's sales administrator, delivered the assessment with blunt clarity. This thing is underpowered, overpriced, and it won't sell. Business 2.0 magazine would later name the Toyota Crown one of the top 5 failed products in business history, a distinction that placed it alongside New Coke and the Ford Edsel. Yet, this failure taught Toyota everything it needed to know. The company's engineers studied its American highways, measured American driving patterns, surveyed American preferences. They learned that Americans valued speed, smooth operation at sustained high velocities, and reliable performance in extreme temperatures from Minnesota winters to Arizona summers. The Crown's failure became the foundation for future success because Toyota treated it as a learning opportunity rather than a reason to abandon the market. Meanwhile, Datsun, which would later become Nissan, debuted alongside Toyota at the Los Angeles Imported Car Show in January 1958. Their engineer, Shinmaki, lost both front teeth when his head went through a windshield during California testing, a sacrifice that proved prophetic of Japanese automakers' willingness to learn from painful experience. Unlike the Crown, early Datsun models showed promise. The Datsun 210 won an uphill drag race against the Volkswagen Beetle during pre-market testing, suggesting that Japanese engineering could compete when properly adapted to American conditions. Rising from ashes, the post-war miracle. To understand how Japanese automakers accomplished what they did, you must first understand the extraordinary circumstances from which they emerged. On September 2, 1945, Japan surrendered to Allied forces, ending World War II. The nation's industrial capacity lay in ruins. American bombing campaigns had destroyed factories, infrastructure, and entire cities. By 1946, industrial production had collapsed to just 27.6% of pre-war levels. The country teetered on the edge of mass starvation, averted only by American food shipments. Toyota, which had produced trucks for the Japanese military during the war, was nearly designated for dissolution under anti-monopoly laws designed to prevent the reformation of military-industrial complexes. By 1949, the company employed 3,000 people, but had no functioning production facilities. In June 1950, Toyota managed to produce only 300 trucks and faced imminent bankruptcy. Salvation came from an unexpected source. When the Korean War began, the United States Army needed vehicles urgently and placed orders for more than 5,000 trucks with Japanese manufacturers. This military contract saved Toyota from extinction, providing the cash flow needed to rebuild operations. But far more transformative than military orders was the arrival of an American statistician named W. Edwards Deming. In 1950, the Union of Japanese Scientists and Engineers invited Deming to teach statistical quality control methods to Japanese managers. Deming was a disciple of Walter Shewhart, who had developed statistical process control at Bell Laboratories in the 1920s. His methods had been largely ignored by American manufacturers, who believed quality came through inspection after production, rather than designing manufacturing processes to prevent defects. The Japanese listened with the intensity of students who understood their nation's survival depended on learning. Deming taught them to view quality not as an acceptable level of defects, but as a systematic approach to eliminating variation in manufacturing processes. He emphasized that inspection detected defects but did nothing to prevent them. True quality came from designing processes where defects couldn't occur. Deming predicted that if Japanese manufacturers implemented his methods rigorously, Japan would become economically competitive with Western nations within 5 years. The prediction proved conservative. Within 18 months, Japanese manufacturers demonstrated tremendous improvements in quality and productivity. The transformation was so profound that Japan established the Deming Prize in 1951 as the nation's most prestigious quality award. To this day, Toyota's headquarters in Tokyo displays a larger-than-life photograph of W. Edwards Deming, alongside images of the company's founder and chairman. The American approach to manufacturing accepted something called acceptable quality level, which tolerated a certain percentage of defects as economically rational. If inspecting every unit cost more than the losses from defective units that reached customers, companies accepted the defects. Deming's philosophy rejected this entirely. He taught the Japanese to design manufacturing systems that made defects impossible, a concept that would eventually evolve into the Toyota production system. The irony is profound. An American taught the Japanese the quality methods that American companies had rejected. Those methods would eventually be used to build automobiles that Americans preferred over vehicles built by their own companies. The seeds of Detroit's future struggles were planted in Japan's post-war industrial rebirth, cultivated by an American consultant whose countrymen wouldn't listen. When the oil stopped flowing, the crisis of 1973, The trajectory of Japanese automakers in America changed forever on October 17, 1973. That day, following President Richard Nixon's decision to request $2.2 billion in emergency aid to Israel during the Yom Kippur War, the Organization of Arab Petroleum Exporting Countries imposed an oil embargo on the United States. Though the embargo cut only about 7% of the U.S. petroleum supply, the psychological and economic impacts were profound. Gas prices surged from 38.5 cents per gallon in May 1973 to 55.1 cents by June 1974, a 43% increase in 13 months. In some areas, prices quadrupled from 25 cents to over $1 per gallon. The price of crude oil leaped from $2.90 per barrel before the embargo to $11.65 by January 1974, fundamentally altering the economics of automobile operation. The American Automobile Association reported that up to 20% of the country's gas stations had no fuel during the worst week of the crisis. Images of cars lined up for hours at gas stations became iconic symbols of American vulnerability. Odd, even rationing systems forced drivers to purchase gasoline only on certain days based on whether their license plate numbers ended in odd or even digits. Oregon banned Christmas and commercial lighting entirely to conserve energy. Congress enacted a 55-mile-per-hour national speed limit to reduce fuel consumption, and the term gas guzzler became an epithet rather than a badge of American automotive pride. American automakers, whose fleets averaged 12 to 15 miles per gallon, suddenly found their vehicles unsellable. The Ford Mustang, Chevrolet Camaro, and Dodge Charger that had defined American automotive culture now seemed like profligate dinosaurs consuming resources Americans could no longer afford. Detroit scrambled to develop smaller, more efficient vehicles, but years of design and engineering work couldn't be compressed into months. Japanese automakers had precisely what American consumers desperately needed. The Honda Civic, introduced in July 1972, featured a revolutionary engine called CVCC, which stood for Compound Vortex Controlled Combustion. This ingenious design achieved 41 miles per gallon on the highway, nearly double what American subcompact cars delivered. More remarkably, the CVCC engine was the first to pass 1975 emissions requirements under the Clean Air Act, tested in December 1972, using a Nissan Sunny body because Honda didn't yet have a large enough vehicle for the testing protocol. The CVCC technology required no catalytic converter, a significant advantage during an era when catalytic converters were expensive, unreliable, and required unleaded gasoline that wasn't universally available. Honda's marketing slogan, "Any kind of gas," became irresistibly compelling to consumers who couldn't reliably find unleaded fuel. The engine could run efficiently on leaded or unleaded gasoline, premium or regular, giving owners flexibility during fuel shortages. The sales surge was staggering. Japanese market share rose from 1.4% in 1970 to 21% by 1980. Honda's U.S. sales increased ninefold, from 39,000 vehicles in 1973 to 353,000 in 1979. Japanese passenger car exports to America exploded from 100,000 in 1965 to 1,827,000 in 1975, an 18-fold increase in just 10 years. By 1980, Japanese manufacturers were exporting nearly 2 million cars annually to the United States, more than they sold domestically in Japan. American consumers discovered that Japanese cars offered more than fuel efficiency. They were reliable in ways that surprised buyers accustomed to frequent repairs. They started consistently in cold weather. They required less maintenance. They held their value better than domestic competitors. The oil crisis opened the door, but quality kept it open even after fuel prices eventually stabilized. Detroit stumbles when giants fell. While Japanese manufacturers offered fuel-efficient, reliable vehicles precisely suited to the crisis, Detroit's responses became cautionary tales of corporate hubris and rushed engineering. Two vehicles in particular symbolized American automakers' failure to understand what the market needed. The Ford Pinto was developed in just 25 months under Lee Iacocca's mandate to produce a car under $2,000 and under 2,000 pounds. The compressed development timeline created an environment where corners were cut and safety concerns were overridden by cost considerations. The Pinto's rear-mounted fuel tank, positioned behind the rear axle with minimal protection, proved vulnerable to rupture and fire in rear-end collisions. The most damning evidence came from an internal Ford memo that calculated the cost of fixing the fuel tank design at $11 per vehicle versus the expected legal settlements from deaths and injuries. The company's cost-benefit analysis concluded it was cheaper to accept the deaths than to implement the fix. When Mother Jones magazine exposed this calculation in 1977, the public reaction was fierce. Sales tumbled more than 50%, and the Pinto became forever known as a four-wheeled firecracker, a symbol of corporate indifference to customer safety. The Chevrolet Vega represented GM's ambitious answer to imports, but it became perhaps an even more emblematic disaster. The car featured an innovative aluminum block engine designed to reduce weight and improve fuel economy. On paper, the concept was sound. In execution, it was catastrophic. The aluminum engine overheated frequently, warped under thermal stress, and consumed excessive oil. Head gaskets failed with depressing regularity. The engine blocks developed cracks. Owners reported that repair bills often exceeded the vehicle's resale value within the first few years of ownership. The Vega's problems extended beyond the engine. Bodies deteriorated rapidly due to rust problems, even in moderate climates. Paint peeled, trim pieces fell off, mechanical components failed prematurely. Motor Trend magazine eventually called it General Motors' worst car, a distinction that spoke volumes given GM's long history. The Vega taught American consumers that domestic manufacturers' quality control had serious, fundamental problems. A survey conducted by economist Rachel Dardis in the 1980s quantified the quality gap with stark clarity. 89 out of 100 American cars had defects compared to 47 out of 100 Japanese cars. The difference wasn't that American quality had declined dramatically. It was that Japanese quality had improved dramatically, while American quality stagnated. Detroit had spent decades accepting mediocrity as economically rational And now consumers had alternatives that demonstrated what was possible. As one economist observed, the damage to Detroit's reputation is something they have never recovered from. American consumers had learned they couldn't trust domestic manufacturers to build reliable vehicles. That lesson, learned through personal experience with Pintos and Vegas and countless other disappointing vehicles, created brand loyalty to Japanese manufacturers that persists to this day. The cars that changed everything. Among the breakthrough vehicles of the 1970s, two Datsuns deserve special recognition for fundamentally transforming American perceptions of Japanese automobiles from cheap imports to desirable vehicles worth owning on their own merits. The Datsun 510, introduced in 1968, earned the nickname the poor man's BMW because Yutaka Katayama, who led Nissan's American operations, deliberately benchmarked it against the BMW 1602 and later the 2002. The 510's 1.6-liter single overhead cam inline-4 engine produced 96 horsepower, respectable for the era. More significantly, it featured four-wheel independent suspension, a rare feature shared only with the Corvette among American cars. The 510's handling was revelatory. It felt nimble and responsive in ways that American sedans, with their soft suspensions and wallowing body motions, simply didn't. Enthusiasts discovered they could drive a 510 quickly on winding roads, something previously associated only with expensive European sports sedans. When Brock Racing Enterprises campaigned iconic red, white, and blue 510s in the Trans Am Racing Series, winning back-to-back championships in 1971 and 1972 by defeating BMW and Alfa Romeo on their own turf. It validated the 510's sporting credentials. American enthusiasts embraced the 510 with an intensity that surprised even Nissan. Here was an affordable sedan that offered European driving dynamics with Japanese reliability and American-friendly pricing. The aftermarket industry began developing performance parts. Racing teams built competition versions. The 510 proved that Japanese cars could be fun, not just practical, and that sporty driving didn't require accepting European levels of maintenance and repair costs. The Datsun 240Z, which arrived in October 1969, may be the single most important Japanese sports car in automotive history. With its 2.4-liter single overhead cam inline-6 engine, producing 151 horsepower, 0 to 60 times of 7.5 to 8.7 seconds, and top speed of 122 miles per hour, the 240Z offered Porsche-level performance at a fraction of the cost. The pricing was devastating to European sports car manufacturers. At $3,526, the 240Z cost less than half of a Porsche 911, which exceeded $8,600, and significantly less than a Jaguar E-Type at $5,725. Car and Driver magazine declared it an almost brilliant car that seems far more expensive than any competitive, similarly priced sports car. Sales exploded from 16,215 units in 1970 to 52,628 in 1972. The 240Z's success was so profound that it changed those opinions instantly and forever, transforming the perception of Japanese cars from cheap tin boxes to genuinely desirable automobiles. American sports car enthusiasts who had previously considered only British and Italian vehicles now seriously considered Japanese alternatives. The 240Z's styling, obviously inspired by the Jaguar E-Type but executed with cleaner lines and better proportions, proved that Japanese designers could create beautiful automobiles. The engineering, with its reliable inline-six and well-sorted chassis, proved that Japanese manufacturers understood sports car dynamics. The pricing proved that Japanese efficiency could bring performance to middle-class enthusiasts who couldn't afford European exotics. Together, the 510 and 240Z accomplished something remarkable. They demonstrated that Japanese cars could be desirable rather than merely practical or fun, rather than merely economical, beautiful, rather than merely functional. They attracted American enthusiasts who cared about driving dynamics and began to view Japanese manufacturers as legitimate alternatives to European brands. This reputation for building engaging, enjoyable vehicles would benefit even mundane Japanese sedans for decades to come. The system that changed manufacturing forever. Beyond individual vehicles, Japanese automakers revolutionized manufacturing itself through a system so effective that it eventually became the global standard studied in business schools worldwide. The Toyota production system, developed between 1948 and 1975 by Taiichi Ohno and Eiji Toyota, emerged from Japan's post-war scarcity and evolved into perhaps the most influential manufacturing methodology of the 20th century. Taiichi Ohno, born in 1912 and often called the father of just-in-time, visited American supermarkets during a trip to the United States and had an epiphany. He observed that supermarkets stocked only what they expected to sell based on actual customer demand, and customers took only what they needed. Inventory moved quickly, waste was minimized, and the entire system operated on a pull principle where demand triggered replenishment rather than production schedules pushing inventory into the system. Ohno realized this principle could revolutionize automobile manufacturing. Traditional mass production, pioneered by Henry Ford, operated on a push system where production schedules determined output regardless of actual demand. Factories produced components in large batches, stored them in warehouses, and assembled them when convenient. This created enormous inventory costs, quality problems hidden until final assembly, and inflexibility when market demands changed. The just-in-time system that Ohno developed inverted this logic. Instead of producing components in advance and storing them, Toyota would produce them just in time to meet demand no sooner and no later. A downstream process would signal exactly when it needed components, and upstream processes would produce exactly that quantity at exactly that time. This pull system eliminated inventory warehousing costs, revealed quality problems immediately when they occurred, and created flexibility to respond to changing customer preferences. The Kanban system, whose name means signboard in Japanese, operationalized just in time through visual cards that triggered production. When a bin of components emptied at an assembly station, The worker would send the Kanban card back to the supplying process, signaling the need for replenishment. The card specified exactly what components were needed in exactly what quantity to be delivered at exactly what time. This created a closed-loop system, providing precise amounts with minimal oversupply. By the early 1970s, nearly all processes at Toyota operated under Kanban. The results were transformative compared to American manufacturers. Inventory turnover rates increased several-fold. Warehouse requirements shrank dramatically. Carrying costs for inventory virtually disappeared. And quality improved because defects were caught immediately rather than being discovered months later during final assembly. The Toyota production system rested on two fundamental pillars that worked together to create its effectiveness. Stores. Jidoka, meaning automation with a human touch, originated with Sakichi Toyota's automatic loom developed between 1896 and 1924. The loom could detect when a thread broke and stop automatically, preventing defective cloth from being woven. Applied to automobile manufacturing, Jidoka meant that machines detected their own inconsistencies and shut down production, preventing defective components from advancing through the system. Just-in-time, synchronized production processes in continuous flow, making only what was needed when it was needed, in the amount needed. Rather than producing large batches and warehousing them, Toyota produced small quantities continuously, matching production precisely to demand. This eliminated the waste of overproduction while ensuring that components arrived exactly when assembly required them. Perhaps the most revolutionary element was the Andon system, which gave assembly line workers the power to stop production. A thin nylon rope hung above the assembly line within easy reach. When a worker encountered a problem, pulling the cord once requested help from team leaders. If the problem couldn't be fixed immediately, a second pull stopped the entire production line. This concept was unthinkable in American factories, where the fundamental imperative was production, production, production. Get volume out. Worry about quality later. Stopping the line meant losing production volume, which meant losing money. Workers who stopped the line in American factories faced disciplinary action. The idea that an assembly line worker had the authority and even the responsibility to stop production if quality was compromised represented a complete inversion of American manufacturing philosophy. But the Andon system embodied Toyota's belief that quality was more important than volume. Better to stop production and fix problems immediately than to produce defective vehicles that would damage the company's reputation and require expensive warranty repairs. The system empowered workers to take responsibility for quality, transforming them from mindless automatons performing repetitive tasks into engaged participants actively maintaining standards. The cumulative effect of these innovations was staggering. By the 1980s, Toyota could produce vehicles with half the labor hours, half the inventory, and half the defects of American manufacturers. The system's efficiency came not from working people harder, but from eliminating waste in all its forms: wasted motion, wasted materials, wasted time, wasted inventory, and wasted human potential. The philosophy that shaped everything. To truly understand how Japanese automakers conquered America, one must look beyond manufacturing systems and examine the cultural philosophies that shaped them. These weren't merely business strategies imported from Western management consultants. They emerged from deep cultural values that had guided Japanese society for centuries, now applied to the challenge of building automobiles. Kaizen, meaning continuous improvement, became perhaps the most famous Japanese business concept exported worldwide. But unlike Western efficiency programs that arrived as top-down mandates, accompanied by consulting fees and PowerPoint presentations, Kaizen was fundamentally democratic and deeply embedded in organizational culture. Every worker, from the newest assembly line employee to the company president, was expected to identify small improvements in their daily work. These weren't dramatic innovations that revolutionized entire processes. They were tiny adjustments, incremental refinements, the kind of changes that individually seemed almost trivial. A worker might suggest repositioning a tool to reduce reach distance by 6 inches. Another might recommend changing the sequence of 2 assembly steps to make the motion more natural. A third might identify a lighting angle that created glare and made inspection more difficult. Individually, these suggestions saved seconds or reduced errors marginally. Collectively, they transformed organizations. At Toyota, workers submitted millions of improvement suggestions annually. During peak years in the 1980s, the company received over 2 million Kaizen suggestions from employees, with implementation rates exceeding 80%. This wasn't a suggestion box where ideas disappeared into bureaucratic review processes. Toyota implemented the vast majority of worker suggestions, usually within days or weeks, and publicly recognized contributors at company meetings and in newsletters. The contrast with American manufacturing culture was profound and revealing. In Detroit's factories, the assembly line worker's job was to perform exactly the same motions in exactly the same sequence hour after hour, day after day, with no deviation. Thinking was management's responsibility. Doing was labor's job. This division of mental and physical labor seemed efficient in theory, but it created massive inefficiencies in practice because the people who knew the work most intimately had no voice in improving it. Imagine having 800,000 people working in your factories, but actively utilizing the brains of only the managers and engineers, while treating everyone else as programmable robots. This represented organizational waste on a staggering scale. Japanese manufacturers understood that workers performing tasks daily developed insights that engineers sitting in offices never could. Harnessing this, distributed intelligence created competitive advantages that rivals couldn't match without cultural transformation. Genshi Jinbutsu, meaning go and see for yourself, insisted that real understanding came only from direct observation at the actual place where work occurred. Toyota executives didn't make decisions based solely on reports, charts, and data presentations. They went to the factory floor, watched actual work with their own eyes, spoke with actual workers performing tasks, and examined actual problems directly. This principle extended to product development. When engineers designed the Lexus LS400, they didn't rely on market research surveys and focus group reports alone. They traveled to Germany, rented Mercedes-Benz and BMW vehicles, drove them thousands of miles across autobahns and mountain roads, dismantled them completely in rented garages, measured every component with calipers and micrometers, photographed every assembly technique, and studied every engineering decision the Germans had made. This hands-on investigation revealed details that no amount of second-hand research could provide. Motainai expressed a profound sense that waste was not merely inefficient, but morally wrong. This ancient concept, often inadequately translated as "what a waste," carried emotional and spiritual weight that simple efficiency calculations could never capture. Rooted in Buddhist principles of respecting all things and maximizing the value received from resources, Motainai shaped how manufacturers approached every aspect of production. In manufacturing context, this philosophy suggested that using every scrap of material, minimizing every unnecessary motion, and eliminating every defect before it required rework weren't just economic imperatives. They reflected deeper values about stewardship and responsibility. A piece of sheet metal represented natural resources extracted from the earth, energy expended in refining and forming, and human effort invested in handling. Wasting it through poor process design could be seen as disrespectful to the material, to the workers, and to the customer, who would ultimately pay for the waste. This cultural framework appears to have created a different relationship to quality and efficiency compared to Western manufacturing, where American manufacturers viewed defects through cost-benefit analysis. If preventing a defect cost more than the defect itself, accept the defect. Japanese manufacturers seem to view defects through the lens of motainai. The defect wasted materials, wasted labor, wasted the customer's money, and damaged trust, making it unacceptable regardless of narrow economic calculations. Omotenashi, the art of selfless hospitality, transformed customer service from a business function measured by metrics into a cultural expression of respect. This wasn't the scripted friendliness of American retail, where employees followed training manuals and managers monitored adherence to standard phrases. Omotenashi meant anticipating needs before they were expressed, providing service that exceeded expectations, creating experiences that made customers feel genuinely valued and cared for. When Lexus recalled those first 8,000 vehicles based on just 2 customer complaints about minor issues, the response embodied omotenashi. Dealers didn't send notices asking owners to schedule service appointments. They called customers personally, apologized for the inconvenience, picked up vehicles at customers' homes or workplaces, completed repairs quickly, and returned vehicles washed, vacuumed, and topped with fuel. This wasn't following a customer service protocol. It was expressing cultural values about respect, responsibility, and the proper relationship between a company and the people who trusted it. The concept of takumi, master craftsmen who had dedicated decades to perfecting highly specialized skills, influenced even highly automated mass production. At Lexus's Tahara plant, Takumi inspectors ran their hands over painted body panels to detect imperfections of less than 0.2 of a millimeter, flaws that were invisible to the eye and undetectable by the most sophisticated measurement equipment available. These craftsmen had trained for decades, developing tactile sensitivity through endless practice to achieve this level of perception. Their presence in a factory full of robots and computer-controlled systems symbolized the Japanese belief that human skill and machine precision should complement each other rather than compete. Automation handled repetitive tasks with consistency. But human judgment, sensitivity, and wisdom remained irreplaceable for achieving true excellence. These philosophies weren't abstract ideals displayed on motivational posters in break rooms. They were embedded in daily operations, reflected in manufacturing processes, visible in finished products, and transmitted through organizational culture. They explained why Japanese factories operated differently, why Japanese vehicles felt different when you opened the door and sat in the driver's seat, and ultimately, why increasing numbers of American consumers preferred them. Quality circles, democracy on the factory floor. In 1962, a group of workers at Nippon Telegraph and Telephone formed the world's first quality circle, a small voluntary group of employees who met regularly to identify and solve work-related problems. The concept spread rapidly through Japanese manufacturing like gentle fire across dry grassland. By the 1980s, Toyota alone had tens of thousands of quality circles involving hundreds of thousands of workers. These were emphatically not management committees. They were voluntary gatherings of frontline employees who knew the work intimately because they performed it daily, hour after hour, developing insights that managers in offices could never possess. A quality circle might consist of 8 workers from a single assembly section who met for an hour each week after their shifts. They would identify problems that frustrated them or slowed their work. A bolt that was difficult to reach, requiring an awkward arm position that caused fatigue. A parts delivery timing that created inefficiency, leaving workers waiting or scrambling. A quality issue that appeared intermittently, suggesting some upstream variation that needed investigation. Then they would analyze root causes, using simple problem-solving tools, propose solutions, test improvements on a small scale, and present results to management with recommendations. The power of quality circles wasn't in any single brilliant insight that revolutionized operations. It was in the aggregate effect of thousands of small improvements implemented continuously across the organization. One quality circle might discover that rotating a parts bin 90 degrees reduced reach distance and save 4 seconds per operation. Multiplied across millions of repetitions annually, those 4 seconds represented thousands of labor hours and reduced strain injuries. Another circle might realize that changing the order of 2 assembly steps eliminated a potential quality defect by ensuring a seal was properly seated before components were installed around it. A third might identify a supplier component that occasionally arrived with slight dimensional variations, work with purchasing to investigate the root cause, and discover that the supplier's measurement equipment needed calibration. American manufacturers tried desperately to copy quality circles during the 1980s, when Japanese competition threatened their survival. But most implementations failed quickly and completely. The problem wasn't the concept itself. It was the organizational culture surrounding it. In American factories, quality circles often became just another top-down program where workers felt pressured to participate to avoid management displeasure. Suggestions disappeared into bureaucratic review processes where committees evaluated them for months. Implemented changes earned no recognition or reward. Workers quickly learned through experience that their ideas didn't actually matter, that quality circles were performative rather than functional, and the entire exercise became an empty ritual performed for management's benefit. In Japanese factories, quality circles succeeded because they were supported by genuine cultural transformation. Management committed to implementing good suggestions quickly, usually within days or weeks rather than months. Workers received public recognition at company meetings, financial rewards for implemented suggestions, and the satisfaction of seeing their ideas improve their own work environment. The and in accord meant workers had real power to stop production when they identified problems, demonstrating that management truly valued quality over blind production volume. Quality circles weren't asking workers to fix management's problems for free while continuing to treat them as interchangeable machine components. They were empowering workers to improve their own jobs, recognizing their expertise, and treating them as valued contributors rather than programmable automatons. This fundamental difference in respect and empowerment explained why the same concept succeeded brilliantly in one culture and failed miserably in another. The results manifested clearly in the vehicles. By the late 1980s, initial quality surveys showed Japanese cars averaged less than half the defects of American vehicles. Industry analysts studying this gap discovered it wasn't that Japanese engineers were inherently smarter or Japanese robots more precise than their American counterparts. The difference was that Japanese manufacturers had successfully harnessed the collective intelligence and experience of their entire workforce, while American manufacturers had tapped only a small fraction of their human potential. The NUMMI miracle, proof that culture mattered more than people. When Toyota and General Motors announced a joint venture in 1984 to reopen GM's shuttered Fremont, California assembly plant, skeptics predicted catastrophic failure. The Fremont facility had earned the worst reputation in the entire U.S. auto industry through years of labor management warfare, spectacular dysfunction, and vehicles so poorly built they damaged GM's brand. Absenteeism rates at Fremont had been among the highest in American manufacturing. Workers used drugs and alcohol openly during shifts. Sabotage was common. Workers intentionally positioned loose bolts inside the door panels to rattle and annoy customers, or assembled components incorrectly to create problems that would only appear after the vehicles were sold. Wildcat strikes erupted regularly over grievances real and imagined. Management and union representatives regarded each other with mutual contempt. The quality of vehicles produced at Fremont was legendarily terrible. Hundreds of misassembled cars littered the holding yard awaiting rework. Some had engines installed backward. Others were missing steering wheels, brakes, or other essential components. Many vehicles had to be towed off the assembly line because they couldn't move under their own power. Quality metrics showed Fremont as the worst performing GM plant in North America, which meant one of the worst in the entire industry. GM had finally closed Fremont in 1982, laying off thousands of workers and abandoning the facility as unsalvageable. The conventional wisdom was clear. The plant was bad, the workers were bad, the union was bad, and nothing could fix it. When Toyota agreed to reopen the plant as NUMMI, New United Motor Manufacturing, Inc., critics assumed the Japanese company had made a terrible mistake. Then Toyota did something that seemed insane. Rather than hiring an entirely new workforce, the company agreed to rehire the same workers who had made Fremont a disaster, including known troublemakers and union militants who had been among the most difficult employees. This wasn't just giving people second chances. It was deliberately recreating the exact conditions that had led to spectacular failure. But Toyota had a theory. The problem at Fremont hadn't been the workers themselves. It had been the management system, the organizational culture, the lack of respect and empowerment, the adversarial relationship between management and labor, and the absence of mechanisms for workers to take pride in their work. Toyota believed that if you treated workers with respect, gave them proper training, empowered them to stop production for quality issues, and created systems that enabled them to succeed, those same workers would produce world-class quality. 257 group leaders and team leaders from the soon-to-reopen plant traveled to Toyota's Takaoka plant in Japan for intensive training during 9 separate sessions. These weren't classroom lectures about theories. Workers spent weeks on actual production lines, learning the Toyota production system through direct practice, seeing how Japanese workers approached their jobs, experiencing the and cord system, participating in quality circles, and absorbing the culture through immersion. The transformation stunned the entire automotive industry. After only 3 months of production, vehicles coming off the NUMMI line had near-perfect quality ratings. Corollas produced at NUMMI were judged equal in quality to those manufactured in Japan, an achievement that seemed impossible given the plant's history. The Harbor Report, the industry's authoritative measure of manufacturing productivity, found NUMMI led all North American assembly plants with just 21.78 labor hours per vehicle. The plant retained 85% of the original Fremont personnel, including many of the same workers who had been labeled troublemakers and saboteurs. Yet, under the Toyota system, these workers achieved world-class quality and productivity. Former militant union leaders, who had led strikes and fought management, became the strongest advocates for the new system after experiencing how it treated workers with dignity and respect. As John Shook observed in MIT Sloan Management Review after studying NUMMI extensively, the union and workers didn't just accept Toyota's system, they embraced it with passion. Workers who had sabotaged vehicles under the old system now stopped production using the and cord to maintain quality standards. The same people, the same facility, but a completely different culture and completely different results, suggesting that the fundamental variable was management philosophy rather than worker capability. Over its 26-year existence, NUMMI produced nearly 8 million cars and trucks while maintaining its reputation for quality and efficiency. The plant proved conclusively that American workers could achieve Japanese-level quality when given proper training, appropriate systems, genuine empowerment, and respectful treatment. The evidence indicated the problem had never been the American workforce. It appeared to be American management philosophy. The bitter irony cuts deeply, despite having what amounted to a front-row seat at a master class in lean manufacturing for over 15 years. General Motors largely failed to implement these methods in its other plants. Organizational rigidity, middle management resistance, and cultural inertia blocked implementation. CEO John F. Smith, Jr. attempted to spread the Toyota production system to other GM facilities, but proved largely unsuccessful. The company couldn't or wouldn't transform its culture even when the path to success was illuminated before them. When NUMMI closed in April 2010 following GM's bankruptcy, the facility was eventually sold to Tesla. The Japanese methodology that had transformed American workers' productivity and quality now powers America's electric vehicle revolution. The lessons learned at NUMMI influenced manufacturing far beyond automotive. But GM itself, despite years of direct access to Toyota's methods, never fully absorbed them. The transplant invasion, manufacturing comes to America. Honda made history on November 1st, 1982, when a silver gray Accord sedan with license plate USA001 rolled off the production line at Marysville, Ohio. This was the first Japanese automobile built in America, a watershed moment that transformed the dynamics of the industry. That original Accord now resides in the Henry Ford Museum in Dearborn, Michigan, a symbol of how profoundly the automotive landscape had shifted. Honda's decision to build vehicles in America wasn't purely strategic calculation. The company brought its respect for the individual philosophy across the Pacific, creating a workplace culture fundamentally different from traditional American auto plants. Associates, not employees, worked in teams rather than rigid hierarchies. Everyone wore the same uniform regardless of position. Managers and executives sat in open offices alongside engineers rather than secluded executive suites. The cafeteria served everyone the same food with no special dining areas for management. These might seem like minor details, symbolic gestures without substance, but they reflected and reinforced a culture where workers were genuinely valued contributors rather than interchangeable components. Associates were encouraged to submit improvement suggestions, given extensive cross-training in multiple positions involved in quality decisions, and empowered to stop production if they identified problems. The culture that had made Honda successful in Japan was transplanted to Ohio soil. By 2024, Honda's cumulative U.S. investments would exceed $9 billion, with manufacturing facilities directly employing over 20,000 Honda associates. The Marysville plant expanded repeatedly, adding capacity and new models, becoming a cornerstone of Ohio's manufacturing economy, and proof that Japanese manufacturing methods could thrive in America's heartland. Nissan followed Honda's example, opening its Smyrna, Tennessee plant in 1983. The first vehicle produced was a white Nissan 720 pickup truck that rolled off the line on June 16, 1983. The $660 million initial investment represented the largest direct Japanese investment in the United States at that time, a statement of Nissan's long-term commitment to American manufacturing. The plant location wasn't accidental. Tennessee was selected partly for its right-to-work laws, which meant workers weren't required to join unions, and the plant has remained non-union throughout its history. This gave Nissan flexibility to implement Japanese management practices without navigating complex union contracts designed for adversarial labor relations. The plant became the first foreign automaker to bring vehicle assembly to the southern United States, beginning a trend that would reshape the region's economy. Current capacity at Smyrna exceeds 640,000 vehicles per year, making it the highest capacity automotive plant in North America as of 2017. The facility produces multiple Nissan models and has become integral to the company's North American operations, employing thousands of Tennessee residents and creating thousands more jobs in the surrounding supplier network. Toyota's wholly owned Georgetown, Kentucky plant broke ground in May 1986 and produced its first Camry on May 26, 1988. The $1.1 billion initial investment created what would eventually become Toyota's largest vehicle manufacturing plant in the entire world, a facility that would produce millions of America's most popular vehicles. The hiring process revealed the appeal of Japanese manufacturers as employers. Over 100,000 people applied for approximately 3,000 initial production positions. Applicants underwent extensive screening, including skills assessments, problem-solving tests, teamwork evaluations, and intensive interviews. Toyota sought workers who could thrive in its culture, not just perform repetitive tasks, and the selection process reflected that priority. By 2014, the Georgetown plant had produced 10 million vehicles, the first Toyota facility outside Japan to reach that milestone. The plant now manufactures the Camry, America's best-selling car for decades, along with the RAV4 Hybrid and Lexus ES. Approximately 75% of each Camry's content is sourced domestically, making vehicles produced in Kentucky more American by content percentage than many vehicles from domestic manufacturers. These transplant facilities transformed American manufacturing in ways that extended far beyond automotive. They demonstrated that world-class manufacturing was possible in the United States. When proper systems, training, and culture were implemented, they forced American manufacturers to reconsider their labor relations, quality systems, and production methods. They created high-paying manufacturing jobs in regions that had seen industrial decline. They trained thousands of American workers and managers in lean manufacturing principles, who then spread these methods to other industries. The transplants also complicated trade politics. How could you restrict imports of Japanese cars when they were built in Kentucky by American workers? How could you argue for protecting American jobs when Japanese companies were creating those jobs? The transplants made Japanese manufacturers genuinely American companies in every sense except ownership, and even that distinction blurred as American pension funds and investors bought large stakes in Japanese firms. The voluntary restraint that backfired spectacularly. By 1980, Japanese imports occupied over 20% of the U.S. market, and Detroit's Big Three had collectively lost $4 billion. Some 300,000 plant workers had been laid off, with another 500,000 workers at parts. Suppliers affected by the production decline. The political pressure to restrict Japanese imports became overwhelming. Rather than face formal import quotas imposed by Congress, Japan agreed in May 1981 to voluntary export restraints that limited exports to 1.68 million cars per year. The policy was intended to give American manufacturers breathing room to recover, improve quality, and develop competitive vehicles. Instead, it backfired in ways that helped Japanese manufacturers while harming American consumers and ultimately failing to save Detroit. Japanese car prices in the U.S. averaged $1,200 higher during 1986 to 1990, a 14% increase directly attributable to the artificial scarcity created by the quotas. But Japanese manufacturers didn't suffer from this price increase. They profited enormously from it. Economic studies found that two-thirds of the price increase came from improved quality and features rather than artificial scarcity. Japanese manufacturers responded to export limits by shifting their product mix from lower-quality entry-level vehicles to higher-quality, feature-rich models that commanded premium prices. The restrictions also spurred massive Japanese investment in U.S. manufacturing, since vehicles built domestically didn't count against export limits. By 1990, all major Japanese automakers had established U.S. production facilities, making future import restrictions impossible to enforce. They were no longer foreign manufacturers exporting to America. They were American manufacturers employing American workers. Consumer costs amounted to $8.9 billion during 1981 to 1984 alone, while U.S. producers captured benefits of only $403 million. Detroit received a cumulative profit boost of approximately $10 billion over the 1980s from the price umbrella the quotas created. But rather than using this windfall to fundamentally improve products, operations, and culture, American manufacturers largely squandered the opportunity, maintaining their quality problems and failing to implement the manufacturing reforms that Japanese competition demanded. Perhaps most ironically, the voluntary export restraints inadvertently created the perfect environment for Japanese luxury brands to emerge. Faced with limits on the number of vehicles they could export but not on their value, Japanese manufacturers had every incentive to maximize profit per vehicle by moving upmarket. The restrictions meant to protect American manufacturers ended up enabling Japanese manufacturers to enter and dominate the luxury segment that had been the most profitable part of the market. Building luxury from scratch, the Lexus story. In August 1983, Toyota chairman Eiji Toyota convened a confidential meeting at a remote location and issued a challenge that would reshape the global luxury automobile market. Create a car that is better than the best in the world. The project, codenamed F1 for Flagship 1, represented an audacious gamble that would eventually cost over $1 billion and consume 7 years of intensive development. Market research had revealed a fundamental problem. Affluent consumers who could afford Mercedes-Benz or BMW would not be caught dead in a Toyota showroom, regardless of the vehicle's quality or features. There existed a price ceiling for mainstream Japanese brands that no amount of engineering could overcome. To compete in the luxury market, Toyota needed a separate brand with no association to its mass-market vehicles, dedicated dealerships that rivaled European luxury showrooms, and a vehicle that could legitimately claim superiority over the best German luxury sedans. The scale of the development effort was unprecedented in Toyota's history. 60 designers, 1,400 engineers organized into 24 separate teams, 2,300 technicians, and 220 support workers. 3,700 people at peak devoted themselves entirely to the V1 project. They built 450 vehicle prototypes and 900 engine prototypes, conducting 2.7 million kilometers of testing across German autobahns, Arizona deserts, Japanese mountain roads, and Saudi Arabian heat. Total development cost exceeded $1 billion, including $400 million spent developing just the one UZFE V8 engine. This represented the largest investment in a single vehicle program in automotive history at that time. Chief engineer Ichiro Suzuki refused to compromise on any specification. When Toyota's director of product engineering told him the targets were impossible and he was out of your mind, Suzuki persisted relentlessly. The LS400 had specific, measurable engineering targets that seemed almost fantastical. Top speed of 155 miles per hour. Cabin noise of just 58 decibels at 100 kilometers per hour. Quieter than many luxury sedans at idle. Drag coefficient under 0.29, better than most sports cars. 0 to 60 acceleration under 8 seconds despite a curb weight exceeding 2 tons. All targets were achieved through obsessive engineering that examined every detail. The 4.0-liter one UZFE V8 that emerged from this development became legendary. It produced 250 horsepower and 260 pound-feet of torque while operating with a whisper-quiet smoothness that astonished automotive journalists. The engine was so perfectly balanced that a champagne glass placed on the hood remained still while the engine ran at idle, a demonstration that became famous and was impossible for European luxury cars to replicate because their engines, while powerful and prestigious, vibrated noticeably. The attention to detail extended far beyond the engine. Car and Driver magazine examined how different manufacturers handled the mundane task of routing wiring through hood hinges. Audi and Mercedes-Benz used basic rubber tubing. BMW covered hinges with molded plastic shields. Lexus featured beautifully formed stampings arranged so that sheared edges of metal were completely hidden, leaving only smooth radii visible. A deep groove in the left side arm concealed wiring with a black rubber welt. All you could see were 2 elegant hinges, one showing an orderly black seam. The magazine called it a sublime execution of a detail most manufacturers ignored. The Lexus LS400 debuted in January 1989 at the Detroit Auto Show and went on sale September 1st, 1989, with a price of $35,000. This pricing strategy proved devastating to European competitors. The LS400 cost about $10,000 less than a BMW 735i and more than $20,000 less than a Mercedes-Benz 420 CL, while offering comparable or superior performance, features, and refinement. Car and Driver's famous December 1989 comparison test delivered the automotive world's verdict in language that couldn't be clearer. Toyota, in its first time at bat in the major leagues, slams one out of the park. The LS400 scored highest in 6 separate categories and topped the overall ballot by a clear margin. Every staff member who drove it loved it. Motor Trend observed it was absolutely staggering to customers test driving both cars that Lexus could deliver the same king-of-the-road presence. the same sense of being over-engineered, all for so little money. Shortly after launch, Lexus demonstrated the customer service philosophy that would become legendary. Based on just 2 customer complaints about minor issues, defective wiring, and overheating brake lights, the company ordered a voluntary recall of all 8,000 vehicles sold. Every vehicle was serviced within 20 days. Dealers personally contacted owners, picked up vehicles at homes or workplaces, completed repairs quickly, and returned cars washed, vacuumed, and topped with fuel. This response established Lexus's customer service reputation more effectively than any advertising campaign could have, and introduced Americans to omotenashi, the Japanese concept of anticipating guests' needs before they're expressed. The company wasn't following a customer service manual or protocol. It was expressing cultural values about respect, responsibility, and the proper relationship between manufacturer and customer. The luxury pioneers and the advertising disaster. Honda had actually beaten Toyota to market by 3 years, launching Acura on March 27, 1986, as the first Japanese luxury brand in America. The decision emerged from Honda's recognition that successful early customers who had bought Civics and Accords in their 20s were now in their 40s with substantially higher incomes and were switching to European luxury brands because there was no Honda model to choose from. The Acura Legend, priced at $19,543, offered a Honda-developed V6 engine, front-wheel drive, and impressive features for the money. It wasn't trying to compete with Mercedes S-Class or BMW 7 Series flagships. It targeted the entry luxury segment where younger affluent buyers wanted premium features without 6-figure price tags. The strategy worked brilliantly. By 1990, Acura topped the J.D. Power Customer Satisfaction Index for 5 consecutive years, outselling both Mercedes-Benz and BMW in the United States. The Acura NSX, launched in 1990, represented perhaps the purest expression of Japanese luxury philosophy applied to sports cars. Developed with extensive input from Formula One world champion Ayrton Senna, the NSX featured the world's first mass-produced all-aluminum monocoque body, approximately 200 kilograms lighter than equivalent steel construction. During February 1989 testing at Suzuka Circuit, Senna provided feedback that demonstrated why Honda sought his involvement. "I'm not sure I can really give you appropriate advice on a mass production car, but I feel it's a little fragile." Rather than dismissing this criticism, the development team responded by raising rigidity targets and spending 8 additional months testing at the Nürburgring, ultimately increasing chassis rigidity by 50% based on Senna's feedback. The result was a supercar that ordinary drivers could use daily, maintaining Honda reliability while delivering performance that rivaled Italian exotics, costing twice as much. Infinity's launch, by contrast, became a cautionary tale demonstrating how even excellent products could fail with disastrous marketing. Nissan rushed the brand to market after learning Lexus's launch timing, debuting the Q45 flagship with an advertising strategy that seemed sophisticated but proved catastrophically misguided. Initial advertisements showed no cars at all. Television commercials featured trickling brooks, gravel pathways, lush foliage, and bales of hay in carefully composed images accompanied by contemplative music. Radio advertisements consisted entirely of nature sounds with no dialogue or vehicle information. Radio station managers despised these commercials because they gave the impression they'd gone off the air. The reasoning behind this approach, that showing the car would make consumers less likely to go to dealerships because they needed to experience it in person, proved spectacularly wrong. Bob Garfield of Advertising Age observed that Infiniti overdid the Zen imagery well into self-parody. Potential customers had no idea what Infiniti was or why they should care. Dealers complained furiously that advertising was generating curiosity but not showroom traffic. By late December 1989, Infiniti scrambled to produce new advertisements featuring 15 photographs of the Q45 with the tagline, "No woods, no rocks, no lakes." But the damage was done. First-year sales reached only 12,000 to 17,000 units compared to Lexus's approximately 60,000, a more than 3-to-1 defeat despite the Q45's superior 0 to 60 time of 6.6 seconds versus 8.3 for the LS400. The Infiniti debacle taught an important lesson that complemented Lexus's success. Excellence in engineering and manufacturing meant nothing if customers didn't know it existed. Lexus succeeded not just because the LS400 was exceptional, but because Lexus communicated that excellence clearly and demonstrated it through customer service that exceeded expectations. Infiniti failed despite building a good vehicle because their marketing obscured rather than revealed the product's strengths. The Camry conquers America. No single vehicle better illustrates Japanese dominance in the American market than the Toyota Camry. Introduced to the United States in 1983 as a replacement for the rear-wheel drive Corona, the Camry was designed specifically and deliberately to succeed with American consumers rather than being a Japanese market vehicle adapted for export. Engineers created slim pillars that maximized visibility, a tall roofline that provided headroom for tall Americans, and prioritized passenger comfort above all other considerations. The engine was smooth and quiet. The ride was compliant without being wallowing. The interior featured quality materials assembled with precision gaps. Everything about the Camry was designed to be pleasant, comfortable, and utterly reliable. The results exceeded even Toyota's optimistic expectations. In 1997, the Camry became America's best-selling passenger car for the first time. With the exception of 2001, when the Honda Accord reclaimed the title, the Camry dominated this category through 2020, a remarkable run spanning most of 2 decades. During its peak years from 2002 through the mid-2010s, the Camry's sales leadership seemed unshakable. By 2013, cumulative U.S. sales had reached 10 million units, with approximately 6.4 million Camrys still on American roads. Annual sales routinely exceeded 400,000 units, peaking at 472,808 in 2007. The Georgetown, Kentucky plant that produced most American Camrys eventually achieved 75% domestically sourced content, making Camrys assembled there more American by parts content than many vehicles from domestic manufacturers. When politicians complained about foreign manufacturers, economists pointed out that Kentucky Camrys employed more American workers and contained more American parts than many vehicles from Detroit. The Camry succeeded not by being the best at any single attribute, but by delivering a complete package that satisfied what most Americans actually wanted from a family sedan. The engine's routinely exceeded 200,000 miles with basic maintenance. Resale values remained strong year after year. The vehicles were comprehensively equipped with comfort and convenience features, and continuous incremental improvements meant each generation was noticeably better than the last. When Toyota introduced the Camry Hybrid in October 2006, it represented another milestone, the first hybrid vehicle manufactured in the United States. Georgetown's production of hybrid Camrys demonstrated that American manufacturing facilities could build advanced powertrains, not just assemble vehicles from imported components. The hybrid Camry became the best-selling hybrid sedan in America, proving that environmental consciousness and Toyota reliability were a compelling combination. The crossover revolution that changed everything. Japanese manufacturers didn't just compete in existing vehicle segments, they created entirely new categories that would eventually dominate the market. The Toyota RAV4, which debuted as a concept at the 1989 Tokyo Motor Show and launched in North America in January 1996, is credited as the first ever compact crossover SUV. Before the RAV4 and Honda CR-V, introduced in 1995, the term crossover didn't exist as a vehicle category. Honda literally had to invent the CR-V name because there was no established term for what they were building. These vehicles combined SUV benefits, cargo room, elevated seating position, available four-wheel drive, with car-like attributes including better fuel economy, superior handling, comfortable rides, and easier entry and exit than truck-based SUVs. Early critics dismissed them as soft rotors unsuitable for serious off-road use, but consumers embraced them enthusiastically because most people never took their SUVs off-road anyway. What Americans actually wanted from SUVs, research revealed, was the commanding view of the road. The perception of safety from sitting higher, the cargo flexibility for family activities, and confidence in bad weather. They didn't need body-on-frame construction, low-range transfer cases, or the ability to ford streams. Car-based crossovers provided everything most people actually use while delivering better fuel economy, superior on-road dynamics, and lower manufacturing costs that translated to lower prices. In 2007, the Honda CR-V became the best-selling SUV in America, defeating the Ford Explorer for the first time since the Explorer had claimed the #1 position in 1991. This represented a fundamental shift in American preferences. The crossover segment grew rapidly, eventually overtaking sedans as the dominant vehicle type in the American market. By February 2020, the RAV4 had sold over 10 million units globally, becoming Toyota's best-selling vehicle worldwide. In 2024, it achieved what once seemed impossible. The RAV4 became America's best-selling individual vehicle model, with 475,193 units sold, surpassing the Ford F-150's 460,915 units for the first time since 2009. This milestone carried an asterisk that Ford was quick to point out. When all F-Series trucks were combined, from F-150 through F-600, which shared cab architecture but differed substantially in capability and purpose, Ford's total exceeded the RAV4. Similarly, if General Motors combined its mechanically identical Chevrolet Silverado and GMC Sierra, their total would surpass the RAV4. But measured as individual model nameplates, The RAV4's achievement was undeniable. A Japanese crossover, a vehicle category that hadn't existed 30 years earlier, now outsold America's iconic full-size pickup truck when compared model to model. The transformation was symbolically profound, representing not just market share, but a fundamental change in what Americans wanted from vehicles and where they were willing to buy them. The reliability revolution that changed expectations. Japanese automakers didn't just build reliable cars. They fundamentally changed what Americans expected from automobiles and made reliability a primary purchase criterion. Consumer Reports reliability surveys, which began in 1952 with 50,000 subscribers, grew to cover over 800,000 responses by 1991, creating the most comprehensive database of real-world vehicle reliability in existence. The results consistently favored Japanese manufacturers with such consistency that it became almost monotonous to report. A 2007 survey found that 34 of 39 models on the most reliable list were from Asian manufacturers, 17 from Toyota, including Lexus and Nissan, 7 from Honda, including Acura, and smaller numbers from Nissan, Hyundai, and Subaru. European and American manufacturers were largely absent from the top reliability rankings. J.D. Power Studies told a similar story year after year. The 2024 U.S. Vehicle Dependability Study ranked Lexus number 1 with 135 problems per 100 vehicles, achieving best overall for the second consecutive year. Toyota placed number 2 with 147 problems per 100 vehicles, best among mass-market brands. The industry average was 190 problems per 100 vehicles, meaning Toyota and Lexus significantly exceeded typical reliability. Toyota Motor Corporation captured 9 segment awards in the 2024 study, the most since 2017, and more than any other manufacturer. These weren't flukes or statistical anomalies. They represented decades of consistent performance that created self-reinforcing reputation advantages. This reliability became self-perpetuating in ways that benefited Japanese manufacturers long after individual model advantages might have narrowed. Toyota and Honda vehicles routinely exceeded 200,000 to 300,000 miles with proper maintenance, creating legions of satisfied owners who replace their vehicles with the same brand. Strong resale values reflected consumer confidence that these vehicles would remain reliable for subsequent owners. The Toyota Certified Used Vehicle Program was ranked number 1 for 16 consecutive years, demonstrating that even used Toyotas commanded premium prices based on reliability reputation. Japanese manufacturers had fundamentally changed what Americans expected from automobiles. Previous generations accepted that cars needed frequent repairs, that quality control was hit or miss, that you hoped to get a good one from the factory but had no real assurance. Japanese manufacturers demonstrated that vehicles could be reliably excellent, that quality could be built in systematically rather than achieved randomly, and that 200,000 miles could be a reasonable expectation rather than an ambitious hope. The hybrid gamble that paid off. In December 1997, Toyota launched the Prius in Japan as the world's first mass-produced hybrid vehicle, a technological gamble that many industry observers predicted would fail. The U.S. launch followed in July 2000 at a price of $19,995. Early sales were modest, just 24,000 units by 2003, double Toyota's original conservative projections, but still clearly a niche product. The second-generation Prius, launched in 2004 with dramatically improved styling and performance, found a much larger audience. Motor Trend named it Car of the Year, and sales began climbing steadily as gasoline prices rose and environmental consciousness grew. The Prius became more than transportation. It became a visible statement about values, a signal that the driver cared about fuel economy and environmental impact. Peak U.S. hybrid enthusiasm arrived in the early 2010s during sustained high gasoline prices. Prius family sales reached 247,230 units in 2012, and hybrid market share hit 3.19% in 2013. Cumulative Prius nameplate sales reached nearly 2 million units by 2016, representing 48% of all U.S. hybrid sales. Globally, the Prius family reached 6.1 million cumulative sales, accounting for 61% of Toyota's 10 million hybrids sold worldwide. Toyota's commitment to hybrids over pure electric vehicles became increasingly controversial, as Tesla demonstrated that battery electric vehicles could be desirable, practical, and profitable. Former CEO Akio Toyoda was openly skeptical of aggressive EV mandates, and Toyota lobbied against policies requiring rapid transitions to battery electric vehicles. Environmental groups, including Greenpeace, ranked Toyota at the bottom of major automakers for decarbonization efforts. The Sierra Club argued that a hybrid today is not green technology, given the urgency of climate change. Yet Toyota maintained its multi-pathway approach, arguing that different markets needed different solutions and that hybrids could reduce transportation emissions faster than waiting for electric vehicle infrastructure to develop globally. The company pointed out that building one battery electric vehicle with a 70 kilowatt-hour battery pack, if those batteries were instead distributed across multiple hybrids with smaller battery packs, would reduce more total emissions by improving fuel economy across more vehicles. The fifth-generation Prius, launched in 2023 with dramatic redesign, 194 horsepower and 57 miles per gallon combined, proved the formula still worked. First quarter 2024, Prius sales surged 138.6% year over year. The car was named North American Car of the Year for the second time in its history and won World Car Design of the Year, validating that hybrids remained relevant even as pure EVs gained market share. In 2024, Toyota's electrified sales, hybrids plus EVs, exceeded 1 million units in the United States for the first time, with hybrids driving the overwhelming majority of that volume. The gamble that began in 1997 had paid off spectacularly, establishing Toyota as the global leader in hybrid technology with decades of development advantage over competitors who had dismissed the technology as a transitional compromise. The EV dilemma: strength becomes weakness. Japanese automakers' enormous strength in hybrid technology paradoxically became a weakness in pure electric vehicles, creating a classic innovator's dilemma. Heavy investment in hybrid drivetrains, manufacturing systems, and supply chains created organizational momentum that was difficult to redirect toward battery electric vehicles. Conservative corporate cultures prioritized perfecting proven technologies over betting on uncertain transitions. Supply chain dependence on China for approximately 60% of rare earth minerals needed for electric motors added geopolitical risk. The Nissan Leaf, launched in December 2010, gave Japan an early lead in electric vehicles that completely evaporated over the following decade. While Leaf sales grew modestly, 11,226 units in 2024, up 57% year over year, Tesla's Model Y sold 372,613 units in the same period, more than 30 times as many. Toyota's BZ4X, launched in 2022 and co-developed with Subaru, sold just 18,570 units in 2024, despite a $6,000 price reduction intended to stimulate demand. Korean competitors' EVs consistently outsold Japanese offerings. The Hyundai Ioniq 5 and Kia EV6 became critical and commercial successes, winning numerous awards and selling in volumes that exceeded all Japanese EVs combined. The surprise success story came from Honda with the Prologue, launched in March 2024 and built on GM's Ultium platform. The Prologue sold 33,017 units in its first partial year, significantly outselling the BZ4X at a higher price point. The result suggested Japanese brands could compete successfully in EVs when they fully committed to competitive products rather than cautious half measures. Toyota announced significant EV investments, including a $14 billion battery plant in Liberty, North Carolina, with production starting in 2025, $1.3 billion for Kentucky plant upgrades to produce three-row EVs starting in 2026, and $1.4 billion for Indiana plant upgrades. Yet simultaneously, Toyota cut its 2026 global EV sales target from 1.5 million to approximately 1 million units, acknowledging that EV adoption was proceeding more slowly than initially projected. The company's much-touted solid-state batteries, promising 40-year lifespans, 521 to 747-mile ranges, and 10-minute charging, have been repeatedly delayed from original 2020 targets to current 2027 to 2028 projections. Whether these batteries will deliver their promised advantages at commercially viable cost remains uncertain, the Korean challenge rising. Perhaps the most significant threat to Japanese automotive dominance comes not from Detroit, but from Seoul. Hyundai Motor Group has risen from 7th in U.S. Automotive rankings in 2019 to 4th place by 2023, surpassing Stellantis for the first time and approaching Ford for the third position. Combined 2023 sales reached a record 1.65 million units, up 12.1% year over year. Hyundai sold 870,370 units. Kia sold 782,451 units, and the Genesis luxury brand sold 69,175 units, up 22.6%. Korean manufacturers have matched Japanese quality through heavy research and development investment, extended warranties offering 10-year, 100,000-mile powertrain coverage, and aggressive U.S. manufacturing expansion. The 2012 Chorus Free Trade Agreement eliminated tariffs on Korean vehicles, and new facilities, including a $7 billion Georgia EV plant scheduled to begin production, have expanded domestic manufacturing. Korean brands' SUV-focused lineups matched American preferences precisely at the moment when crossovers and SUVs overtook sedans as the dominant vehicle type. Genesis has emerged as a genuine threat to Japanese luxury brands, consistently outselling Infiniti and approaching Lexus and Acura in sales volume. The GV70 and GV80 crossovers drive growth, with 2024 third-quarter sales up 28%. In electric vehicle competition, Korean manufacturers lead decisively. The Ioniq 5's sales jumped 143% in the third quarter of 2024, and the Kia EV9 sold over 22,000 units in its first full year, despite premium pricing above $50,000. Korean manufacturers have essentially replicated the Japanese playbook from the 1970s and 1980s. Enter with value-oriented vehicles, establish reliability reputations, gradually move upmarket, invest in domestic manufacturing, and leverage quality improvements to command premium prices. They've done it faster than the Japanese did, benefiting from more advanced manufacturing technology, better initial capital, and lessons learned from watching Japanese success. The merger that wasn't, a glimpse of desperation. On December 23, 2024, Honda and Nissan signed a memorandum of understanding that, had it succeeded, would have fundamentally reshaped the global automotive industry. The proposed merger aimed to create the world's third-largest automaker, with approximately 8 million vehicles combined, and a market value approaching $50 billion. Mitsubishi Motors had been expected to join the partnership, with a holding company planned for Tokyo Stock Exchange listing in August 2026, Honda leading management. The merger reflected harsh realities facing all traditional automakers. Nissan faced severe financial struggles with declining sales and profitability. The company's profits in the 6 months ending September 2024 had plunged 94% compared to the same period in 2023. Chinese EV manufacturers threatened all traditional manufacturers with advanced technology and aggressive pricing. Scale increasingly determined survival in an industry requiring massive investments in electrification, autonomous driving, battery technology, and connected services that few companies could afford independently. Nissan CEO Makoto Uchida acknowledged the situation was severe, an understated assessment of a company that some analysts feared could face bankruptcy as soon as 2026, when huge amounts of debt would come due. Honda CEO Toshihiro Mibe stated, "We anticipate if this integration comes to fruition, we will be able to deliver even greater value to a wider customer base." But it was not to be. By February 2025, barely 6 weeks after the initial announcement, the merger talks collapsed. The breakdown came when Honda proposed changing the structure from a joint holding company to one where Honda would be the parent company and Nissan the subsidiary, a suggestion that Nissan's leadership found unacceptable despite their company's precarious position. The companies announced they would terminate the Memorandum of Understanding, citing the need to prioritize speed of decision-making in an increasingly volatile market environment. The failed merger suggested that corporate pride could override survival instincts even when facing potential extinction. It also hinted at deeper challenges. If two struggling Japanese automakers couldn't agree on terms to merge when facing existential threats, what did that say about the industry's ability to adapt? Historical precedents for automotive mergers offered little comfort. Daimler-Chrysler had famously failed to create promised synergies, and the Renault-Nissan partnership that Nissan was trying to escape from had been troubled for years. What the numbers say today. The 2024 statistics reveal both Japanese strength and emerging challenges that complicate any simple narrative of continued dominance. Toyota sold 2,332,623 vehicles in the United States, up 3.7% year over year, remaining the #1 retail brand for the 13th consecutive year. Lexus achieved its best ever U.S. sales in its 35-year history. The RX remained the top-selling mid-luxury SUV for the 26th consecutive year. Market share tells a more complex and nuanced story. Toyota commands approximately 15 to 16% of the U.S. market, with Honda at roughly 9%. But the combined Big Three, GM, Toyota, and Ford, hold only 45% together, a far cry from domestic manufacturers' 90+% dominance in the 1960s. Hyundai Motor Group's 11% share continues growing, while traditional Japanese brands face pressure from multiple directions. Consumer Reports' 2024 reliability rankings show Japanese brands remain dominant in the categories they pioneered. Subaru #1, Lexus #2, Toyota #3, Honda #4, Acura #5, Mazda #6. 6 of the top 10 brands are Japanese. The Toyota Corolla Hybrid achieved the highest individual model reliability rating at 93 points. Yet Honda slightly trails Kia and Hyundai in some rankings due to concerns about its turbocharged 1.5-liter engine. A reminder that quality leadership requires constant vigilance and can never be taken for granted. Conclusion: the quiet transformation. As you drift toward sleep, consider what this 7-decade transformation really means. The story of Japanese automobiles in America offers enduring lessons about persistence, adaptation, cultural values, and the quiet power of doing things correctly rather than quickly. When Toyota's Crown failed spectacularly in 1957, the company didn't abandon the American market in embarrassment. It learned. Engineers studied what had gone wrong, understood what Americans actually needed, and committed to meeting those needs perfectly rather than adequately. When the oil crisis created opportunity in 1973, Japanese manufacturers were ready with exactly the products consumers desperately needed because they had spent years preparing. When voluntary export restraints threatened to limit growth in 1981, Japanese manufacturers invested billions in American manufacturing, transforming a constraint into competitive advantage and becoming more American than many American companies. When quality surveys consistently showed Japanese superiority throughout the 1980s and 1990s, the evidence suggested this wasn't because of inherently superior people, but because of superior systems, culture, and respect for workers. The Toyota production system, born from post-war scarcity and W. Edwards Deming's quality teachings that American manufacturers had rejected, became the global standard for manufacturing excellence. NUMMI's experience suggested that American workers could achieve Japanese quality levels when given proper systems, training, and respect. The fundamental variable appeared to be management philosophy rather than workforce capability. Lexus demonstrated that meticulous engineering and customer service could disrupt even the most established luxury brands backed by century-long heritage. Excellence mattered more than pedigree. Substance mattered more than image. The LS400 didn't just compete with Mercedes and BMW. It fundamentally changed what luxury meant, forcing European manufacturers to improve quality, service, and value. Today's challenges: electrification, software-defined vehicles, Chinese competition, Korean rivalry, changing consumer preferences, require the same adaptability that transformed Japanese manufacturers from builders of overheating crowns into producers of America's most popular vehicles. The 2024 statistics show Japanese brands remained formidable, dominant in reliability rankings, leading in hybrid technology, commanding significant market share. But the EV transition threatens to reset competitive positions, and Korean manufacturers have proven they can match Japanese quality while moving faster. The next chapter continues to unfold in battery plants under construction in North Carolina in the aftermath of failed merger negotiations between Honda and Nissan, in the quiet factories of Georgetown and Marysville that continue producing vehicles Americans trust, in laboratories developing solid-state batteries and autonomous driving systems. The outcome remains uncertain, whether Japanese manufacturers will adapt as successfully to electrification as they did to efficiency, whether their hybrid expertise will prove an advantage or a burden, whether new competitors will replicate their manufacturing excellence. Whatever happens next, the transformation these manufacturers achieved, from post-war devastation to global leadership, from humiliating failure to dominant success, stands as one of the most remarkable business achievements in modern history. The engines idle quietly, the production lines hum steadily, the vehicles roll off assembly lines in Kentucky and Ohio and Tennessee, built by American workers using Japanese methods, destined for American driveways where they'll serve reliably for decades. The conquest was quiet, achieved through 10,000 small improvements rather than one dramatic revolution, through patience rather than aggression, through quality rather than marketing. As you settle into sleep, let the story fade like headlights disappearing down a long highway at dusk. The details blurring into the general impression of a journey completed, a transformation achieved, a quiet revolution that changed everything while making hardly any noise at all.